our discussion would be about numerical differentiation. So, humana na tatong what was our last topics? The previous week, we discussed about root finding, di ba? Root finding, and there are three methods that we have discussed. The first one was the bisection method. The second was the Newton-Raphson. And the last one is second method. Tama ba? So this time, we will be discussing numerical differentiation. Okay? And after this numerical differentiation, we will also be discussing numerical integration. Sa numerical differentiation class, we'll just cover lang three methods. Una is the forward difference. Okay, this another one is the backward difference, and the last one is the central difference. Okay, so we'll cover each, no? But among these three, yung central difference is the most accurate. Okay, relative to these two. Okay, relative to these two, this is the most accurate numerical differentiation. Okay, you will later know why. Okay, napapamudra, no? Kindly tell me, ha? You can just open your microphone na, sir, medyo ano ka, or kaya you can just message me sa BBL na to, or sa Messenger. Okay, numerical differentiation. So, numerical differentiation involves estimating the derivative of a function f of x using discrete data points rather than algebraic formula. So, very self-explanatory. So, there are functions na they are not given, no? But these are data points. So, meron tayong x and y values nun yan. So, meron tayong data usually, no? Meron tayong table. Okay, at x value, we get y value. Meron tayong ganyan, or we can also, we also have yung mga complex na mga function na hindi natin ma-derive using analytical method or algebraic method. Diba? There are certain rules or mga sinasabi natin yung mga elementary rules, kumbaga, or fundamental rules sa derivative. Like for example, what is the derivative of sine x? So that is cosine of x, tama ba? So on and so forth. Yan yung mga tinatawag nating elementary or fundamental rules of integration. Now dito, okay, we are covering complex function and or discrete data points. So, in numerical differentiation, this is primarily achieved through Taylor series expansion. So, balik pa rin tayo doon sa Taylor series expansion. Now, ito yung sinasabi ko, finite differences. Tatlo ito, the forward, the backward, and the central difference. Okay, mag-una tayo dito sa yung forward. Okay, the derivative of a function f at the point z is defined as the limit of the difference quotient. We know this one from our diff calc, tama ba? So, yung first derivative is actually the limit of this function, di ba? F of x plus h, etong h, so in our discussion, we will be using h instead of, di ba, sa ang natutunan natin sa diff calc is that is delta h, tama ba? Delta x. So, that is f of x, dito delta x. Yun yung natutunan natin sa diff calc, wherein dito in my discussion we will be expressing delta x as h. So dito tatawagin natin tong step size. Okay, step size or incremental value. Okay, step size or incremental value or increment size, yung ganyan, or incremental size or incremental value, the same lang sila, no? Okay, but most often sinasabi or tinatawag natin yang step size. Okay? So sabi dito, the limit of this function as h approaches to 0 is actually the first derivative of that function. Okay? At that point. Okay? Kung ano yung point dito. Now, in other words, the difference, the difference quotient, ito yun guys, is the approximation of the derivative nito. So, whatever function we are given here, yung approximation ng derivative na yun as x approaches to something like this one, or as h approaches to something, okay, is the approximation. Okay, and the more our step size gets smaller, the more accurate or the more better our result is. Okay, or the better our result is. Now, Taylor's theorem with remainder gives the Taylor series expansion. Ito yun, di ba? So, if we will be getting the expansion or Taylor expansion of this one, so let me just check now if nandyan pa kayo. Okay, goods naman. So, if we will be evaluating the Taylor expansion of our f of x plus h, di ba, we have here f of x and then plus yung step size natin, then first derivative ng x, plus, okay, di ba, ma-square yan, ito. Bale, yung x is, yung h, di ba, x minus some value, some value na ililet natin. For example, that's minus a. Then ito, di ba, mag-increase yung exponent yan. So, each succeeding terms, mag-i-increase yung exponent yan. Di ba? We know that from our Taylor series. And then, etong symbol na to, okay, that would represent ng mga succeeding na mga expansions or terms dito. So, we'll just end dito lang sa third term. Okay. Because we are trying to determine ng value ng f of prime. Okay, ito. So, therefore, okay, note that this symbol shown is some number between x and x plus h. Yan yun, ha. And then, rewriting that one, okay, or rearranging, ito, from here, we can rearrange this one by, ito, we can transpose that, magiging f of x plus h yan, minus f of x, tama ba? And then, matitira dito would be h, then f prime of x, plus h square, and then f double prime of some symbol like this one, and then 2 factorial. Okay? Then, we need to divide both by h, so that we can eliminate h here, and then matitira dito will be 1h na lang. Wherein, yung f of x plus h minus f of x over h, ito transpose natin sa kabila, magiging negative of f of prime x is equivalent now to h, then f double prime of the error, then over 2 factorial. Ito, class, is actually the error of this order. Now, ito yung approximation natin, di ba? So, therefore, yung approximation natin, and then this is the true value of our first derivative at that given point x, is actually equivalent to error. Meaning to say, okay, ito na yun, error is equivalent to this one. Now, which tells us that the error is proportional, okay, to h. Now, if we will minimizing this error, therefore, yung etong, if this error is to be minimized, therefore, this one is the approximation, or we call this the first order approximation of our first derivative. Ito na yung magiging general equation natin. Basically, galing lang din yun dito sa limits. So, pinakita lang using Taylor series. Now, there are two. Okay, the first two would be the forward and the backward difference. So, una, if yung h natin or step size is greater than 0 or positive value, we have this one. Okay. Nandyan pa ba kayo? Okay, nandyan pa kayo, no? So, this one. Now, this is called the forward difference approximation. So, ito yung magiging formula natin for the first derivative or the numerical derivation ng ating function given step size. Okay, ito yun, no? Madali lang to, class. Ang mahirap lang dito yung introductory part. Okay? And then, if yung h natin is lesser than 0, we also have this formula. So, ano lang yung na-change, guys? Is yung positioning at saka yung sign dito. So, pag h is positive, so that is forward. Pag h is negative, so mangyari niyan, that is backward. Okay. Yan lang. Okay. Ito na yung sa backward. Okay. Backward difference approximation. Okay. Yun. Okay. And then, how about naman yung central? Okay, di ba? Kapag meron tayong number line, okay, for example, this is the x where we will be evaluating our derivative of the given function. Ito yung backward, no? Ito yung forward. Itong part na to, forward lang yan lahat dyan, no? Ito yung part na to, backward. So, kukunin natin yung central. Okay, meron tayong sa backward, meron tayong sa forward. So, central siya. So, paano yan? Paano i-solve yan? Okay. Using pa rin ng Taylor expansion. Now, we can have the Taylor expansion of f of x plus or negative h, no? And by adding more terms to the expansion, we get this one. So, una, di ba, ito. So, kanina, nag-stop lang tayo dito na part, no? So, we'll add more term. So, as you can see, meron tayong f double prime of x here, then 2 factorial plus h raised to the power of 3 and some error. Nandito na yon, or that will become, this one will describe nung mga succeeding terms. Okay? And then, para naman sa f of x minus h, di ba, positive, negative, so, alternating lang yung magiging sign. So, same pa rin yung numerical value, but yung sign is alternating. Ito magiging positive, negative, positive, negative. Now, if we will be subtracting these two expansion, meaning to say, f of x plus h minus this one, okay, diba mangyari niyan, we have f of x minus, plus h minus f of x minus h, tama ba? Is equivalent to f of x minus f of x, magiging 0 na yan, plus f of prime x, okay, sorry, h of f prime x minus negative hf prime x. So, di ba, magiging negative times negative, magiging positive na yan. Magiging positive 2h f of prime x. So, I hope nakuha niyo, no? Naka-follow pa kayo, class? Anyone from the group? Okay, sige. Naka-follow pa man, no? And then, if we will be subtracting this one by this one, same term sila, same sign, so that would become 0. Nakuha. And then, this one, h3 plus magiging negative times negative, magiging positive na yan. So, magiging 2h3, no? And then, f of triple prime. This one. No. Hindi pala yan magiging 2h3 kasi magkaiba to, no? So, mangyari niyan, h3. Then, we have here f of triple prime. Okay, this symbol. Plus, ito. Okay. This symbol. Then, we have here 3 factorial. Wherein yung 3 factorial natin is equivalent sa 3 times 3 times, meron pala, wala na pala, tama to, 3 times 3, 3 times 2 times 1, which is 6, no? So, gawin natin is that we will be transposing naman dito. Okay, what we can do is, first, we will be dividing this by 2h so that we can get rid of 2h here. Ito din, magiging 2h yan dito. Lahat yan, no? Okay, hold on, ha? Okay, so if we will be dividing it by 2h, so ang mangyari niyan, ganito. So, we have here, subtracting this expansion, ito na yun, di ba? Ito na yun dito. Okay, then, and then, if we will be dividing both sides, okay, sorry, we get this one, no? And if we will dividing both sides by 2h, ito yun. Okay, so that yung ma-isolate is yung f of prime x lang, okay, then we get this one, okay, we get this one, okay, ito, divide natin by 2h, ito, magiging 2h yan, so mangyari ganito na yan, no? And then matira dito is f of prime x, kasi makancel yan, and then ito, makancel to, magiging dalawa na lang, then 2 times 6 magiging 12, yan na yun, di ba? And then, transpose natin sa kabila, so therefore, this is the approximation ng first derivative using central difference approximation. So, therefore, itong term na to will approximate our first derivative whose error is proportional to ito. Ito yung magiging error niya. Okay? Nakuha niyo ba? So, basically, you just need to memorize etong mismo na formula at saka yung dalawa, yung backward and forward difference approximation. At saka ito. Yun lang yun. Kapag first derivative. Now, using similar pattern for higher order differentiation, so i-increase natin yung expansion, ha. So if we will be increasing the expansion, okay, we try to get here the second derivative of the given function. So, if we will be increasing the function or the expansion, sorry, and then that is for x plus h, no? Pag x minus h naman, ito na yun, di ba? Alternating lang, same value pa rin yan, no? But as you can see, nag-stop tayo dun sa ika-fifth na term. And then we have here f triple prime. Now, this time, para ma-eliminate natin yung ang gusto natin kunin is yung f double prime, tama ba? Now, if we will be subtracting that one, yung h2 dito tapos minus h2, makancel yung f double prime. So, hindi natin makukuha yung second derivative, tama ba? So, what we need to do is to add. We will be adding these two terms. So, if we will be adding that one, f of x plus h, okay, plus, ito yon f of x minus h. So, ito magiging 2 of f of x. Itong dalawa. Ito, makancel na yan, no? Tapos, ito, makancel na din. Okay? So, plus, ito dalawa, 2h square f of double prime x. Then, that is 2 factorial. Wherein 2 factorial is 2 times 2, which is 2 lang pa rin, no? Then, cancel ito. And then, plus, ito, h of raised to the power of 4. Then, f of f4 e1 plus f4 e2, no? Yan yun. And then, we have here, 4 factorial is 24. 4 times 3, which is 12 times 2, which is 24. Okay, yan na yun. And then, ito, isolate natin yung, basically, yung f double prime, isolate natin, no? So, f of x plus h, ito, from positive, magiging negative yan. And then, we have here plus f of x minus h, no? And then, we will be dividing both sides by h squared. Para, matira dito would be equivalent sa f of double prime x, no? Okay. Plus, ito, divide natin by h squared, magiging h raised to the power of 2 na lang yan. Tama ba? H raised to the power of 4 divide h squared, h squared pa rin. Okay, so copy lang dito, no? So, ito, copy lang dyan. Copy. Now, okay, now, ito, transpose natin sa kabila. Basically, ito na part will approximate our second derivative. Okay, itong value na to will approximate our second derivative. So, basically, no? Basically, we have this formula. So, ito na part here will approximate our second derivative with error proportional to the square of the step size. Okay. So, basically, this one will approximate our second derivative. I hope, no, nakuha ninyo yung derivation. Basically, no, you just need to memorize yung forward, backward, at saka central difference, saka yung second derivative formula ito. Now, with similar pattern, makukuha nyo din yung formula ng third derivative, fourth derivative, and so on and so forth. Higher order derivative. Pero for this ano lang, we'll just stop na lang siguro with the second derivative. Okay? So, you just need to memorize this one. But, if you wish to derive, no, the third order, gamitin niyo lang yung pattern or yung, yes, similar pattern pa rin. So, using Taylor series. Kaya, ganun ka-importante yung Taylor expansion because magagamit yan, no, sa, kagaya nito, magagamit yan. Okay, nandiyan pa ba kayo? Kindly thumbs up or kindly react naman, no? Okay, hilumon man kayo mo. Okay, sige. We'll start answering some problems, no? I have prepared here 3 problems. So, ito lang yung magiging problems ng numerical differentiation. And tomorrow, ito namang isa. Okay. Ito yung part na discrete data points, no? Ito din yung part na yung may equation talaga. Okay, may given equation. I know, madali lang itong equation na binigay ko, no? So, it can be solved analytically or using elementary equations or rules, but since we are dealing with numerical differentiation, we'll apply numerical differentiation here. And then we'll try to compare na lang with analytical, But again, numerical differentiation is helpful if we are dealing with complex function na di na natin alam yung numerical, yung elementary derivation rule for that. Okay, sige. Sige, I'll just move sa another, eto, using OneNote. Okay, para dito tayo magsasolve class. Okay, given the function f of x equivalent to x cubed minus 2x squared plus 4, approximate the derivative at x equivalent to 2 using a step size of 0.1. So, una, try natin yan i-derive using analytical method. Okay. Para i-compare lang natin, no? 'Di ba? We know for that that is f of prime x, that is the derivative. What is the derivative of x cubed? That is 3x squared minus derivative ng 2. Sorry, nandiyan pa ba kayo? Kindly ano naman, no? Kindly tawag ni respond. Okay, what is the derivative ng 2x squared?
4x, sir.
Okay, 4x plus 0, no? So, you evaluate naman if yung x is equivalent to 2, di ba? So, normally, ginagawa natin ganyan. No? 3 times 2 square minus 4 times 2. Anong value nito, guys? Anong value nito? 3 times 4, that is 12 minus 8, no? And that is equivalent to 4. Tama ba?
4, sir.
Okay,
Yes,
4 yung dapat nating makuha, no? Or closest to 4 kasi numerical tayo. Numerical method. So, with numerical differentiation, so using, again you can use forward, backward, pero for me, ang gagamitin ko is yung central kasi mas accurate yung central. So, siguro, we'll be using na lang central. Okay? Central difference approximation. So, that is f of x plus yung step size natin, okay? Minus f of x minus h, yung step size natin, all over h. H ba yun or 2h? Kalimutan ko. H lang. Sorry. Kalimutan ko. Is 2h pala. 2h. Okay. Tama na 2h. So, 2h yan. So, yung f of prime of x natin would be equivalent or approximate equivalent to ito yung formula. Okay? So, madali lang yan, no? So, first, we need to evaluate yung x natin is 2 plus yung step size 0.1. So, we will be evaluating the function at 2.01. So, that will become 2.01 cubed minus 2 times 2.01 squared plus 4. Okay, give me the value of our f 2 plus 01. Ito, guys. Sige daw, 2.01 01 ba? Ay, mali pala, no? 0.1 pala to. 2.1 then 2.1, sorry. Okay, this is 2.1 cube. Guys, paki ano naman, no? Calculator. So, do we have the same answer?
Yes, sir.
Okay. So, that is 4.441. Okay. This one is 4.441. Now, okay. Now, how about yung f of x minus, magiging 2 minus 0.1. So, basically, we have here 1.99. Tama ba? Cube minus 2 times 1.99. Sorry. 1.99. 1.9 pala. Sorry. Plus 4. How about this one, guys? So, 1.9, okay, cube minus 2 times 1.9 square plus 4. We have here 3.639, no? 3.639. Okay, then plugin natin dun sa ating CF na tawag nito, Central Difference Approximation or CDA. Okay, CDA. So, yung f of x natin or f prime of x which is at 2, no? So, that is equivalent sa 4.441 minus 3.639. Okay, 2 times 0.1. Okay, kindly give me the value of this one, Nobe. 4.441 minus 3.639 divide 2 times 0.1. And the answer is 4.0. Okay, do you have questions? Okay, do you have questions? 4.0. Okay, 4.01. Tama. Okay, di ba? 4.01. Okay, so very close to our expected value. So, yan yung way, no? On how you can use the uh, central difference approximation. Now, okay lang yan kasi dali lang analytical method, no? Dali lang din itong numerical method. Pero what if we're given with complex function? So, mahirap na yung analytical method. Mas madali na yung numerical method. So, yan yung maganda dito sa numerical method. Okay, sige. Let's try another one, no? Approximate the derivative of f of x equivalent to sine of x at x is equivalent to pi over 4 using step size of 0.05. So, the more smaller or the smaller your step size is, the more accurate your derivative or the approximation of your derivative. Okay? Okay, so sige. Using na lang diretso, di na tayo analytical method kasi as you can see, makita niyo naman yung comparison nito. Okay? So, let's start with this one. Okay, yung f of x natin, again, that is f of x plus yung step size minus f of x minus yung step size all over 2h. So, ano yung f of x? Pi over 4 plus yung step size 0.05. So, ano yung pi over 4? Pi over 4, okay, plus 0.05. So, that is, okay, kailangan nyo yan i-shift store A. Dapat exact value yung kukunin natin, no? And then, if you have A now, so, balik kayo dito, sine. So, make sure din na naka-radian mode kayo, ha? Dito, naka-degree mode yan, no? Shift mode, radian. Kapag may trigonometry, sine x, so, automatic radian dapat. So, alpha, okay, gawin natin alpha x yan dito. Then, calc, then yung x natin will be equal to A. Okay, so the answer would be 0.741. Okay, closest to gawin natin, let's copy the 4 decimal places tayo. 474, okay, 16. Okay, yan yung value ng f of pi over 4 plus 0.05. Now, ngayon naman, pi over 4 minus 0.05. That is equivalent sa, okay, yung calc, yung x natin would be equivalent sa, that is pi divide 4, okay, minus 0.05. Okay, that is equivalent sa 0.6709. Okay, then therefore, we have here our answer, 0.7416 minus 0.6709 all over 2 times 0.05. Okay, kindly give me the value of our f of 4. Kindly give me the value of our derivative. Sige, paki-open na lang your microphone, no? 0.7416 minus 0.6709 all over 2 times 0.05. And that is equivalent sa 0.707. And that is your answer. Now, if we compare it with analytical, so 'di ba? Dali lang 'yan, no? So, derivative. So, ito shift derive of sin x, no? Gamitin natin yung power of calculator, no? At pi over 4. So, the answer would be equivalent to 0.707. So, okay, ano lang sila, malapit lang talaga. Okay, the more smaller or the smaller the step size is, mas accurate yung magiging sagot natin. Okay? So, this is only applicable kapag meron tayong i-evaluate na derivative given a point. Pero pag wala yung point, pero pag may choices, madali lang din mag-ano lang kayo tawag nito. Mag-assign na kayo ng values for x. Okay, so last problem for the day, no? Given the function f of x equivalent to e raised to the power of 2x, approximate the second derivative at x equivalent to 1 using a step size of 0.1. Okay. So, I know some of you, hindi na alam siguro paano to i-derive, no? So, if we will try to recall, if we have e raised to the power of u, and the derivative of that is eu ln of e, then du over dx. Tama ba? Or that is simply eu du over dx kasi itong ln e is equivalent sa 1, no? So, if using analytical method, that is equivalent to e raised to the power of 2x, then derivative ng 2x, that is 2. Okay? So, if we will evaluate this when x is equivalent to 1, so, ang sagot nito would be equal to 2e raised to the power of 2. Yan yung sagot natin. Or in decimal, that is about 2 e raised to the power of 2. Okay, that is about 14.778. Okay, 14.778. Now, using analytical numerical method, okay, using our CDA, okay, central difference approximation, okay, using a step size of 0.1, so that is f of 1 plus 0.1 minus f of 1 minus 0.1, okay, all over 2 times 0.1. Value ng f of, okay, sulat natin yung function natin, e raised to the power of 2x, no, alpha x. So, yung x, okay, calc natin, yung x is 1 plus 0.1, that is equivalent to 9.02, okay, hold on, 9.025, okay, minus, okay, then we have here calc, okay, 1 minus 0.1, that is equivalent to 6.04, and sabihin natin 96, all over 2 times 0.1. Okay, sagot nito equivalent sa 9.025 minus 6.0496 all over 2 times 0.1, and that is equivalent to 14.877. Okay, 14.877. Okay, almost the same nung sagot natin, expected na sagot. Okay? Tama ba yung ano? Okay, balikan ko 2 raised to the power of e, no, raised to the power of 2. Baka nabaliktad ko lang, 778 talaga. Okay, so therefore, this is your answer for using numerical differentiation. So, I hope na nakuha nyo yun, no? So, I'll just upload this one, okay, para ma-review nyo.